Good morning, I am Ablesh. In this session, we are going to see about radiation loss from the subject heat and mass transfer. Black body radiation. A black body is defined as a perfect emitter and absorber of radiation at a specified temperature and wavelength. No surface can emit more energy than black body. A black body absorbs all incident radiation regardless of wavelength and directions. First one, Stephen Boltzmann law. The radiation emitted by a black body per unit time and per unit surface area is expressed as E suffix b is equal to lambda T power 4, the unit is volt per meter square, and the Stephen Boltzmann constant, that is lambda is equal to 5.67 10 to the power minus 8 watt per meter square. T is absolute temperature in Kelvin. This is also called as black body emission power. Spectral black body emission power, also called as monochromatic emission power, is the amount of radiation energy emitted by a black body at an absolute temperature, that is T, per unit time per unit surface area at a particular wavelength lambda. Second is a Planck's distribution law. The relation for the spectral black body emission power, that is EB lambda, is known as Planck's distribution law, and it is expressed by C1 by lambda power 5, that exponential into C2 by lambda T minus 1. This formula gives the magnitude of the emitted energy at each of the wavelength which comprise the whole radiations. It is a diagram for Planck's distribution law. The emitted radiation is a continuous function of wavelength at a specified temperature. It increases with the wavelength reaches a peak and then decreases with increasing wavelength. At a wavelength, the amount of emitted radiation increases with the increasing temperature. As temperature increases, the curve gets steeper and shifted to left to the shorter wavelength region. A large fraction of radiation is emitted at a shorter wavelength at higher temperature. The wavelength at which a peak occurs for a specific temperature is given as Wien's displacement law, lambda T is equal to 2897.8 mu meter Kelvin. Emissivity. The emissivity is a surface is defined as the ratio of radiation emitted by the surface to the radiation emitted by a black body at a same surface temperature. The emissivity is denoted by epsilon. At its value varies from 0 to 1. The emissivity is the measure of how closely a surface approximates a black body for which epsilon is equal to 1. The emissivity of surface substances, these are the conditions for vegetarian, water, skin, building material, paints, soil rocks, and then glass minerals, carbon, ceramics, oxides materials, the metals, unpolished metals and polished metals all. The absorptivity, reflectivity and transmittivity. The fraction of irradiation absorbed by a surface is called as absorptivity, and the fraction reflected by a surface is called as reflectivity. The fraction transmitted is called as transmittivity. We can see in the clearly we can see in this diagram. Reflectivity, an actual or irregular reflection is shown in the first diagram, and then specular reflection is shown in the second diagram. The angle of reflection equal the angle of incident of a radiation beam. And next one is a diffuse reflection. Radiation is reflected equally in all directions. Absorptivity. The absorptivity depends upon the temperature of the source at which the incident radiation is originating. For example, the concrete roof is 0.6 for solar radiation and 0.9 for surrounding radiation from trees and buildings. It's a diagram for examples. Kirchhoff's law. The total hemispherical emissivity of the surface at temperature T is equal to its total hemispherical absorptivity for radiation coming from a black body at the same temperature. The emissivity T is equal to alpha T. In this, glass transmits over 90% of radiation in visible radiation region, and it is practically opaque to the radiation in the longer wavelength range, but entire radiation is emitted by the surface at room temperature, then it falls in an infrared region. Glass allows the solar radiation to enter but does not allow the infrared radiation from the interior surface to exit. This causes a rise in interior temperature, is known as greenhouse effect. It is small object is cavity. In a large cavity, the area A1 by A2 is equal to 0, and the F1, that is F factor, F1 F into 1 2 is equal to 1. For infinite large parallel plates, the A into A1 is equal to A2 is equal to A, and F1 2 is equal to the phase 1 and 2 is equal to 1. Thank you.